On this page, I just want to get into some basic definitions that you would touch on much more in an actual differential equations class, but I just want you to have heard them and kind of have a sense of what they are. So an equation involving an unknown function and its derivatives is called a differential equation. We already saw that. The order of a differential equation, this you might have heard of before. The order of a differential equation is the highest order that appears on a derivative in the equation. So if you remember learning critical values in Calc 1, sometimes your instructor will call them first order critical values because they were the critical values for the first derivative, or second order critical values. Those are the potential inflection points, which were when the second derivative is equal to 0. All right, so the orders of these particular functions is the highest derivative that appears, which in this case is the first derivative. So that's 1, order of 1. This has a second derivative, so that's an order 2. This has a first derivative again, and that's the only derivative out there, so that's a 1. And that little parentheses, of course, means the third derivative, so that's an order 3. All right, now a linear differential equation is if the unknown function y and its derivative appear only in the first power and are not composed with other functions. You don't have a function nested inside another one. So if you look at this first one, for example, I have dy dx, that's first power. I have 4y, that's first power, and there's no composition of other functions here. So I just have cosine of x. So this is linear. Similarly, this second one is also linear because it's got a second derivative, right? But that second derivative is only to the first power. I have a function, and that's about it. So it's linear. Both of these, however, are not. This is not linear because of the y squared right there, right? You cannot have a function composed with another function. So you can't put y into something else. And also, the function y has to appear only to the first power, right? So that's a problem right there. Oh, this is the composition one, sorry. So this one on the left, no powers allowed, right? Only to the first power. So this is y to the second power, so that is not linear. This one has a y composed inside another function, so this is not linear. All right, and last but not least, the most important one for us, which is a first order linear differential equation. It has to have the form where the derivative dy dt is equal to, or plus p of t times y is equal to q of t. And of course, it doesn't have to be t. It just can be t, so some other variable. So p of t and q of t are given functions of t. Note that y and y prime appear to the first power. So y right here is to the first power, y right here is to the first power, and y prime, which is right here, is to the first power. And they're not in products, nor are they in compositions that involve y or y prime. So you can have this product here, but it's not a product of y with another y or y with y prime. Right? It's just y times some random function with t. So of those, which is a first order linear differential equation? And the answer is this one. This one's a first order linear differential equation. I have a derivative, I have a function, there's p of t is 4. I have y equals q of t right there. This is not because it's not first order, right? So right there, that's why that one's not. So that's a big no. Has to be only the first power or first derivative, y prime. And this one's not because of the y squared, so that's no good. It was already not linear because of that. And this is not for two reasons. One, you can't have the third derivative, and two, you can't have a composition. So this is doubly not.